So where I want to start here, though, is to simply draw, again, the 3-carbon alcohol of glycerol. And remind you that over here, we're now going to make a fatty acid. The characteristic of fatty acid is the double bonded oxygen and an OH. And then the great long chain of carbons, and I won't put the hydrogens on them. And again, we have here another fatty acid. With some enzymatic magic, we can synthesize a new molecule here. And we're going to use something known as dehydration synthesis. In the dehydration synthesis, what we'll do is we'll take the hydroxyl, the OH, from the carboxylic acid, and we'll combine it with the hydrogen on the alcohol of this carbon. That's then going to generate a water molecule. The water molecule will contain the hydrogen from the alcohol and the hydroxyl from the carboxylic acid. That's the genesis of the water molecule. But in the process of generating that water molecule, we'll also produce a new bond. The new bond is going to be this carbon-oxygen-carbon bond. And because this carbon contains a double bonded oxygen on it, this is an ester bond. To generate a triglyceride, we can repeat the process for all 3 of these carbons. So now we have the ester bonds. The ester bonds are now the covalent linkage between the glycerol, the glycerol and the fatty acid side chains. So we have 3 fatty acid side chains. Attached to the glycerol, and this now is, of course, a triglyceride. The hallmark of the triglyceride, of course, is that it's hydrophobic. The equal sharing of electrons among all of these hydrogens and carbons out on the long fatty acid side chains leaves the molecule with practically no distributed charge. It's evenly charged all along the molecules. Because of the lack of charge, it doesn't easily interact with the dipole moments on water. Over here, we're going to change that structure just a little bit. And we're going to now generate a phospholipid. The phospholipid is going to, in many ways, look like the triglyceride. It has 3 carbons. This carbon is linked through the ester bond to a great long chain of fatty acids. A great long chain of carbons. That's true for the number 2 carbon as well. Carbon, oxygen, carbon, double bonded oxygen, generating the ester bond, the great long chain. So we can say here that we have two fatty acid chains. But on this number 3 carbon, on the third carbon, we're going to change the structure just a little bit. Now, rather than having an ester bond to a great long chain of carbons, we're going to take this carbon. We're now going to link it through an oxygen to a phosphorus to an oxygen. And this double bonded oxygen up here in the phosphorus and a single bonded oxygen that's negatively charged down there. Then this oxygen is going to be linked to 2 carbons normally. And this carbon then out here can be linked to an amine. So this now is said to be phosphatidyl ethanolamine. Ethanol being, this started out as a hydroxyl here, so it was an ethanol. It has an amine on it. Now, don't memorize all that structure, but what I want you to know is that this amine is now going to be positively charged. At biological pHs, it's going to pick up an extra hydrogen. It will be positively charged. There's another related molecule, which is called phosphatidyl choline. Phosphatidylcholine looks a whole lot like this. Phosphatidylcholine, again, has these 2 carbons. And out here, it has a nitrogen. And then on the nitrogen, there are 3 methyls. And again, it's not the details of the individual atoms we're concerned with here. What we're really concerned with here is that by the time we put these methyls on here and we share the charge, this nitrogen becomes positively charged. So now look what we've done. We have taken a triglyceride where the charge is evenly distributed throughout the molecule. A triglyceride which is hydrophobic and will not interact with water in a regular fashion. It's much happier to form globules of itself. So now we have a molecule with 2 fatty acid side chains whose hallmark is that they are hydrophobic. But in addition, there's this phosphate head group. That's charged. There's a shorthand to this. The shorthand to this is that we use a circle to represent the phosphate head group. And then we simply draw a couple of squiggles to represent the fatty acid side chains.